Okay, this is section 3, and in section 3, we actually are considering kind of going back to structural strength and stability, um, but in respect to the properties or the characteristics of certain materials, okay, and how they're put together. So the first thing we're going to look at are the properties of materials. These are actually the characteristics that they have. So if you had to describe something, um, this is how you would describe them, is by their characteristics. So here's some classic, and I'll give you a little bit of a list here, but let's look at some examples. So first of all, a brick, one of its characteristics is it's very hard or rigid. Okay, elastics, they are flexible. Okay, stainless steel, we could say, is very shiny or it's rust resistant. Okay, so those types of things. Oh, I got another one here. Iron, when things are built with iron, iron is very strong, very durable. So strong and durable, those are characteristics. Okay. Now, it's important to consider the purpose of the structure, like what is that structure going to be able to do when you choose the material. So for example, if you're building a new prototype for a bike, you wouldn't choose the cardboard to build it. You know, you wouldn't go, well, cardboard's pretty cheap. I'm going to build a bike out of that, because it wouldn't be able to fulfill its overall function or purpose if it was built with cardboard. It wouldn't last very long, right? So it's very important to consider what your structure is going to be able to do before you start choosing the materials. So here's a list. I'm just going to ramble on a few different types of characteristics that materials might have. So you could go, color is a characteristic that material could have. So color, its luster or how shiny it is, how the texture of the material, how smooth or rough it is. It could be strong, it could be bendable, something could be waterproof, rigid. Did I use that one already? Can't remember. So those are all examples of characteristics. Now the characteristics don't mean what the function of the material is or what the thing does. It just describes it. Okay, and that's key. That's very important. Okay, here's an example, just a little activity we did to help you pick a structure and then identify some parts and things like that. It's kind of good to go over. Now, depending on what you're looking at, actually this is kind of an extension of certain characteristics. Depending on what the characteristics are, a structure could, when a force is applied to it, when a force is applied to it, it might deform or it might not, right? If it's flexible enough, then when a load is applied to it or a force is applied to it, it will bend or twist in whichever way, right? And then be able to go back to its original shape. That's flexibility. Some materials are flexible. So after a force has been applied to it, it will bend. So it will bend under a force without breaking. That's kind of a no-brainer. But then the structure is able to regain its original shape. An elastic band, something that's elastic, is a really good example of that. Okay. Now, a lot of structures can't do that, though. A lot of things. So deformation is when something changes. It's a permanent, I should put in there, permanent change of shape in a structure. So when the structure is being bent or manipulated under force, the structure is not able to regain its original shape. That's being deformed. So like a pop can, right? If you crush it and then you try to like push out those parts, right, so that it's the same shape as it was originally, you'll never be able to do it. Those bends, you just can't get rid of them, right? So that's deformation. So there's some examples of that. Now, quickly, I'm going to look at different types of joints. Now, when people think of joints, they think of like your elbow and a door hinge, and they are joints, okay? But they're only one type of joint. So first of all, a joint is the point. It's where two parts of a structure are connected, okay? So sometimes that connection will allow there to be movement. So it will be considered movable, and sometimes it's considered non-movable. Okay, so if it's movable, obviously it's going to allow movement. That's where your elbow, right? Your elbow connects the top part of your arm to the back half of your arm, and it allows movement there. The door hinge allows movement between the door frame and the door itself. Those are movable joints. A non-movable joint is one where obviously those two parts are not going to move. Okay? So an example would be, well, look at the desk that you sit in at school. Okay, the different parts of the desk are held together with welds, with screws, with rivets, and their purpose is to keep them all together and not allow movement. Okay, so that's a good example of a non-movable joint. Some other non-movable joints are things that are attached, right? So if you look at the outlet on the wall, right? The plug-in outlet on the wall, we don't want that to move. We want it to stay right where it is. So it's held there with some screws. So that joining there, that joint is non-movable. There's no movement between the wall and the face of the outlet. Okay? So you can take a little time trying to think of some other things that are movable and non-movable joints as well. Now, that leads us to, friction. Okay. Now, friction, I'm going to squeeze this in here just because it's kind of all attached. So friction, this is really good. Friction is a force, that acts to reduce movement. Okay. So the more friction between two surfaces, the less movement there will be. And in some cases, that's what we want, right? We want there to be friction. So if I'm hiking somewhere and I have really slippery shoes, right? So that means there's not going to be much friction between my shoe and the ground. Right? That's very movable. That's not going to be good for me, especially if I'm, I don't know, walking across ice or something slippery like rock, right? I want there to be friction so I don't slip. Okay. Now, if you're skating, you want there to be very little friction, right? And that allows you to skate across the ice and life is good. Okay, so it just depends on what you're doing. So this question right here, talks about how can you create greater friction within a joint. I'm going to list, you can pause right now and try to come up with your own, but here's a list of things that will increase the amount of friction. The mass of the object. So if I go over to a student that's sitting in a desk, and maybe they're quite small, maybe we'll go grade 1 student. I could pull that desk across the floor no problem because their mass is quite small. But if I go to some very large football player, linesman, high school grade 12 boy, his mass is going to be very large, and it's going to be very difficult to pull his desk across the floor, right? So increased friction. Okay. A rougher surface. Okay, the rougher the surface is between those two, the rougher the surface between those two parts that are in contact, the harder it is to pull, to move, the greater friction there is, so less movement will result. Okay, those are two main ones. You could probably think through and come up with a few other ones. Here, let me give you another one. So the size of the force between the two surfaces. I'm just going to say force between surfaces. Have you ever tried to warm up your hands by rubbing them together? Okay. So what happens if you push really hard against your hands and continue rubbing? It heats up even more. That means there's more friction, right? So the more force, I guess opposite forces between those two surfaces, the more force there between the surfaces, the greater friction and the less movement there will be. Okay, it's kind of related to mass because mass will definitely show that there's more force, but not always. Okay. I think I'm gonna leave it at that. Those are your kind of your three main ones, and that will do. We did come up with a couple other ones in class, but this is good.